Hello guys, my name is Letian, the project manager for Group One. I am here today with Drakey and Rugvid. We are very excited to present the demo tool of the MedSync hospital information system. For this sprint, our primary focus was delivering a working software. Our core MVP scenario covers the complete patient journey, starting with the front desk with the receptionist and ending in the examination room with the doctor. And we'll be demonstrating how these two distinct workflow operates and communicate with each other. So let's start with the front desk. Um, the receptionist log in and register, books a new patient and register them into an appointment, and finally assign them to a doctor. Um, Based on the feedback that we received from demo one, we made some significant improvements to the patient intake process to make it faster and more user-friendly. First, instead of manually typing out every single piece of patient information, a receptionist now can simply input a patient's insurance number, and the system will automatically fetch and autofill their data, um, like this. And you can also register a brand new patient data from the list. By confirming the um, registration, we can see the Elena Rodrigue um, has been added to the list. Um, Next, we build a fully interactive doctor schedule view. Like if, as you can see, if I select this doctor, John Doe, the receptionist can easily toggle off between different dates and to check the doctor's availability. To assign a patient to a doctor, we implement a seamless drag and drop feature. The receptionist can just drag the patient from the list directly into an open time slot like this. If a patient plan change, the receptionist can also cancel the appointment right here, like with a simple one click or in the schedule. Um, And then before we move to the doctor views, I want to like highlight how we engineer the modularity in our system. Our entire front end is built within building use a component-based design and following the principle of separation of concerns. The interactive schedule and the patient list and the form are all like decoupled, independent React component. This modular architecture allows our team to update and scale the drag and drop scheduling logic without ever risking breaking the patient intake forms. And then next part, I will show you the uh, doctor consultation for workflow, which is what happened when the patient goes into the examination room and log out. Mhm. I'm now logging as Dr. Sarah Lee, our cardiology specialist. This is our brand new doctor workbench, specifically designed so the doctor has everything they need in one screen. On the left side, we have patient queue. The doctor can see the complete appointments, who is up next, and the current active patient. And in this case, John Doe flagged as urgent. In the center is active consultation area. The vials like blood pressure, heart rate, temperature, and oxygen are already loaded in. Below that, the doctor has space to type clinical notes and a search bar to attach standardized primary diagnosis. Um, Finally, on the right side, we have patient insights. For the patient safety, the system explicitly alerts the doctor to known allergies and current medication to prevent adverse drug interaction. Right above that is the prescription interface, where the doctor simply select the medication, dosage, and frequency, and click Add Prescription to finalize the visit. Um, to make all of this front-end interaction actually work, we need the data to flow safely. And so I'm now going to hand it over to Rugve to demonstrate the database driving the software and um, explain our backend architecture.
Thanks, Mike. Hi, I'm Rugved. I own the database layer for MedSync. So the schema has 7 tables, as you can see on the screen. Rather than going through each one, here's the core structure. So users is about doctors, receptionists, and admins. Everyone who logs in has a role field that controls what they can access. The patients table is about people receiving treatment. Separate from users, patients don't log in. The appointments table is about linking a patient to a doctor at a specific time. Status tracks whether it's scheduled, completed, or cancelled. The medical records is about what happened during the visit, like diagnosis, prescription, treatment plan. And the AI notes plus lab reports is about AI generated summaries and test results, both linked back to the medical record. The most impactful thing I built this sprint was the insurance registry table, which isn't in the ER diagram, as you can see. The UI team designed a feature where instead of manually typing a patient's info, the receptionist just enters an insurance number and the fills itself. And I want to quickly cover how these software quality principles are built into the database layer, not just stated, but actually engineered in. Talking about modularity, the database is a fully independent layer. The front end, back end, and database are each separate concerns. The schema itself is modular too. Each table owns exactly one concept with no data duplicated across tables. If the backend team needs to change how they fetch appointments, they don't touch the schema. So if I update the schema, they just update their queries, clean separation. Talking about the second component, scalability. So I chose PostgreSQL specifically because it handles concurrent connections. SQLite, which we originally listed, breaks the moment when two users hit the application at the same time. The normalized schema means that we can grow to thousands of patients without restructuring. And the insurance registry is designed as a standalone table. When we are ready to replace it with a real external API, nothing else in the schema changes. And coming to the last component, which is the security, three specific decisions here. First, the app connects using a dedicated MedSync user account with only the privileges it needs, not the admin account. Second, the role field on the user table has a hard database level constraint. So invalid roles literally cannot be inserted, even if someone sends a bad API request. Third, passwords are stored as hashes, never plain text. To wrap up, the database is live wired to the backend and powering everything you see in the app. The schema is modular. The tech choice was made for scalability and security is enforced at the database level. So that's my part. Now I'll be moving it forward to Draki, who will be explaining the API design layer.
Hi, I'm Draki, and my part is working on the API layer, the Spring Boot backend that sits between the React frontend and the Postgres SQL database. So we basically designed it around three service area. First is the auth and security service API. Uh, this manages the staff login and role-based access control. We have four roles in the system: doctor, nurse, receptionist, and admin. The idea is that when the user logs in, the API issues a JWT token, and the token gates every protected role route by role, so a receptionist can access doctor-only endpoints. So a receptionist can access doctor-only endpoints. Second, the patient management API. This handles the patient intake flow. When a receptionist enters a insurance number, the API calls our insurance registry lookup endpoint, autofills the patient form, and then register them into the system. It also lets doctor pull up a patient's full medical history, lab reports, and diagnose records. Third, a scheduling and routing API. This powers the dashboard. It filters available doctor by department and date, returns the daily schedule with open time slots, and lets receptionists assign and book patients to specific appointment slots. So, for the three for modularity, scalability, and security. For modularity, if you look up our backend code, everything is organized into clean, separate layers. We have entities, repositories, controller, and config for each in their own package. Every database table get its own entity class, its own repository, and own controller. So, for example, if tomorrow we need to change how appointment work, we go into the appointment files and nothing else is affected. For scalability, we were intentionally about not overfetching data. Instead of returning the full database objects every time, we created projection interface like appointment slot and workbench appointment that only return the exact fields the front end actually needs. The schedule endpoint also take a date parameter, so it queries one day at a time instead of pulling every appointment ever created. And because each feature area lives in its own controller, if this system ever need to scale, we could break those out into separate microservices without rewriting everything. For security part, a few things. So the password will not just be stored as plain text. They will be encrypted in our database. On the API side, we add JSON ignore on the password field, which means if someone hits the user endpoint, the hash never shows up in the response. We also configure the course so only our front-end origin can call the API. Random website can't just hit our endpoints. And the insurance lookup checks that the policy is actually active before returning any patient data. Once we add the Spring security with JWT tokens, the role field on each user, doctor, nurse, receptionist, admin, maps, maps directly to route level permission. So a receptionist can access doctor-only endpoints. So that's the three parts that we figure out, and that's my part. I think thank you for watching. That's all.